Welcome guys to a whole new video, and in this video I'm going to show you guys how you can use AI to perform pen test activities and identify vulnerabilities in websites. So the website chosen for today is a vulnerable banking web server called Commando X, and this is their public GitHub repository. And Commando X is designed to simulate a real financial institution that is operating on the web interface, similar to most banks nowadays. And ideally, what I want to show you guys is how you can use AI to perform basic enumeration, scanning, and also run brute force attacks and see if you can expose any user credentials and passwords in the vulnerable banking web database. So for this video, I'm going to show you guys how we can deploy a simple vulnerable banking server. This will be our target website, and the vulnerable banking web server that we've chosen is Commando X. For those of you guys who are not familiar with Commando X, we have their GitHub repository over here, and I'll also attach the link in my description. And this video will showcase how attackers can deploy various methods, and we'll try and run a couple of attacks and active scans and see how we can expose some of the sensitive data that is in this specific vulnerable banking web server. So this server is designed to be vulnerable, as you can see, and we are going to exploit various features, and as you can see, we have different core banking features that hold very sensitive data. So first things first, what you're going to do is register on AWS, then we'll launch an instance and we'll give it a name. So you might as well give it Commando X. Then for the specific OS image, we're going to choose Ubuntu. For the AMI type, we're going to leave it to the default selection. For the instance type, you can choose different instances depending on what you want, but for this case we're going to use the T3 micro instance. Then we're going to generate a new key pair, and in this case we're going to use this new key pair to SSH into the machine. So depending on the authentication method that you want to use to shell into this machine, you can use the PEM file through SSH, or you can download the PPK file and SSH using PuTTY. So in my case, I'm going to use the PPK file and give it a name. So we can give it target bank. Then for the key pair type, we're going to use the RSA encryption type. Then we create the key pair. For the network settings, what we're going to do is we're going to allow HTTP and HTTPS traffic. So this depends on whether you're going to configure any certificates, SSL certificates on your vulnerable banking web server. So let's say in a scenario where you're trying to showcase a realistic environment, then you can use HTTPS traffic to demonstrate that it's a realistic website that is having an SSL certificate installed, like most websites do. And we're going to allow all these options, and also we'll modify some of these rules so we can also allow outbound connection and firewall traffic to our SSH machine. So for the storage, we're going to give it a rather big storage. We can give it 16 GB of storage. Then we'll leave the rest of the settings to the default settings. So right now we've given a name to our vulnerable banking web server, specified the operating system, which is Ubuntu, and we've added a couple of rules to the firewall security group. So you simply click launch instance, and we'll wait for AWS to create our EC2 instance that is running on Ubuntu. So you basically give it some time in order to run and install all the instances in our machine. Then once it's initialized, we'll SSH into the server and install Commando X vulnerable banking web server. So go back to instances, and right now as you can see, this is our previous machine that I was experimenting with, but we have our deployed machine over here that is initializing, so I'll give it some time to complete the status check. So we've already downloaded our ppk file, and this is what we're going to use with party in order to SSH into the machine and install Commando X. So right now we have our bank initialized, and we're ready to SSH into the machine. So what you'll do is we'll open party. If you don't have party downloaded in your machine, then you can go to the official website and download party, or you can use SSH from your command line interface to SSH into your machine and use the PEM SSH key file. So we'll open party, and here what we'll do is we'll first of all select our machine, copy our public DNS address, and switch over to party and insert it as the host name. Then you're going to add our ppk file, so we'll click on SSH, then authentication, select credentials, and in this case we're going to load our private key file which has the ppk extension. And once you've selected that, click on open and we'll SSH, select accept, and use the default username which is Ubuntu, and we'll wait for it to SSH into the machine. So I'll move this to the right side of my screen, and before we clone the vulnerable banking application GitHub repository, run some updates, run sudo apt-get update, then we'll also run an upgrade. So right now we have our list of repositories updated, and we've also upgraded our system. So the next thing to do is we're going to follow the steps listed on our GitHub repository. And in this scenario, we're going to use option 2. But if you want to use option 1, then you can install Docker in your EC2 instance, then use option 1. But in this case, you're going to use the local installation method. So you clone into the repository, then change the directory. Next step is you're going to set and create a virtual environment. So since you're running on a Ubuntu server, we're going to use the second option. And as you can see, guys, we don't have a Python virtual environment installed in our machine. So what we'll do is we'll install a Python virtual environment, and in this case we're going to install Python version 3.12 as our virtual environment. So run the command as sudo So now, since we have our Python virtual environment packages installed in our machine, what we're going to do is we're going to create and activate our virtual environment, and we use the commands specified for the Linux environment. So right now we've switched to our virtual environment. So what we'll do is we'll proceed to install the required packages that are listed in the requirements.txt file, and the installer that we're going to use is pip, and we'll give it some time to install the listed packages. So right now we have our listed packages installed in our machine. The other thing that we're going to do is we're going to create a new directory called static, then we'll specify another directory called uploads, and I will use this command. And right now we have a new directory created. The next thing that we're going to do is we're going to modify our .env file. So our .env file is listed in this current directory. So if we list all the files, we can see we have an env file, .example file. So just nano to that file and see the details in this specific file. So in our env file, the instructions are to change the DB host from DB to localhost. So we'll do exactly that. Then for the database name, we'll leave it to the default settings. The database user, same. So we'll Control X to save the file. So the next thing to do is run the application using the Python command. We'll use Python 3. And I wanted to show you guys the errors that you'll get if you use the default installation methods. As you can see, guys, we're having multiple errors over here where the server is not accepting any TCP/IP connections. So what you'll do is we'll first of all exit out of our machine. Then what we'll do is we'll modify some of the security group settings. And in this case, what we want to do first is modify the security inbound rules of the firewall so that we can add a specific port that is running on post GRE, which is 5432. We'll add it as a part of our inbound rules. And the other port that we're going to add is port 5000, because that is the specific port that is running our web interface, which is port 5000. So we'll also modify that. And in order to modify the rules in your EC2 instance, go to your EC2 instance, select it, and go to security, then select the security groups. And what we want to do here is modify our inbound rules, and we'll create 2 new rules. So this is custom TCP rule, and the port that we specify is port 5432, originating from any address. Save that rule. So it's automatically detected that this is a post-GRE SQL port, which will allow us to access our post-GRE database. So the other rule that we're going to add is a specific port, which is port 5000, that we're going to access the web interface from, and we'll save the rules. So right now we've modified our inbound rules and we've added 2 new rules. This is the first rule on port 5432. Then we have a custom TCP rule we've created to allow us connectivity via port 5000. The next thing that you're going to do, we've already prepared a worksheet file So we'll just follow along this file and follow the steps that are listed in this file. I'll make a point of attaching a link, or if you can just send me a DM, I can share this specific document so that you can follow the steps when you want to troubleshoot some of the settings. So the first thing that we're going to do is we're going to install PostGRE, and before we do that, we'll update our repository list again. So what we'll do is we'll SSH again into party, and we'll specify our host IP address. So we'll go back to our EC2 instance, go to the details, extract our public DNS, then we'll go to SSH, authentication, credentials, then we'll SSH into the server. So similar to what we did, we're going to log in using the default username, which is Ubuntu, and we'll navigate to our vulnerable banking web server directory, and we'll basically follow the steps that are showcased in this document. So copy and paste to update our repository list and also install PostGRE SQL. The next thing we're going to do is we're going to enable PostGRE and also start it. Then we're going to verify if PostGRE is running as required. So if it's active, then it means PostGRE is running on the machine. And as you can see, guys, we have the green button over here which showcases PostGRE is running on our machine. So right now we'll attempt to create and set a database password name, and it should match the details that are listed in our environment example file. So just to confirm, we have our environment example file where we modified our database host to fit the local host description as instructed on GitHub. So let me just nano into that. And this is our local host which we modified. Basically, the new database that we'll create on PostGRE should match these credentials that are listed in our env file, and we'll do exactly that. So first of all, we'll shell into our PostGRE backend database that is running on SQL. And right now we are in our backend database. So what we'll do is create a new database called vulnerable bank, and we'll use create database command. Then you're going to alter the user and add this specific password that is listed over here. Then we'll quit PostGRE. So let's follow that. And right now we're going to confirm if everything matches. And as you can see, guys, everything matches our listed details that are in the env file. So the next thing is you're going to activate our virtual environment again, then run the Python app file. So we'll go back and we'll activate our virtual environment. Then we'll run our Python application file. So right now you can see that Commando X initializes successfully, and we've been given a specific web interface where we can access this specific directory. Remember guys, the IP address that you're given over here is a private IP address which can only be accessed by machines that are in the same VPC as this specific EC2 instance. But in our case, we want to access it from our normal browser, and what you'll do is go back to your EC2 instance, and as you can see guys, we have our private IPv4 address, and we also have our public IPv4 address. So in this specific URL, you can modify and use a different, let me just use an incognito browser. So we modify our IP address and we'll use the public IPv4 address. So we've already installed Commando X Vulnerable Banking Web Server. Once you start the Python app file, it should give you a direct URL to access the web interface. And let's see if we can access the front-end side of the website. So remember, it's running on HTTP, but in realistic scenarios, what you want to do is configure and set up an SSL certificate so it can run on HTTPS traffic. And also make sure that you modify the inbound rules on your firewall from AWS so it can allow traffic coming from Commando X Vulnerable Bank Web Server. So we are going to run our first attack, which will be an active Nmap scan against our Commando X banking web server. And in order to access our banking web server, we're going to use Party, and this time you're simulating the attack on Kali that has some of the tools that we can run the scans using Nmap. So in order to start Party, simply type Party on your terminal. Then it will give you a similar interface to what you get on Windows, and right here what we'll do is we'll copy our public DNS and paste it on the host name. Then we'll specify our credential keys, which is our private key file, our PPK file, and you can simply click on open and you'll SSH into your machine. Right now we've successfully SSH'd from our Kali machine, and remember guys, this machine is what we're going to use as our attacker virtual machine. And before I conduct an Nmap scan, what I'll do is I'll install Apache. In most cases, if you have instances or web servers that are running on Ubuntu, then some organizations use Apache to set up the website and the host interface in navigating on the website. So we're going to install Apache. Before we do that, we're going to run an update. So we can get an updated list of repository files. Then we'll run sudo apt install to install Apache 2. Type yes. And the third thing we're going to do is we're going to allow Apache on our firewall configurations. So copy this command the command is sudo ufw app, then lists the rules, and right now we can see Apache is listed as one of our available applications. So we're going to allow Apache. And it's already updated our rules, so just to confirm, we'll verify our firewall status. The next thing is we're going to check the status of Apache. And you can see Apache is already running. Remember, before we set up our Commando X server, we created firewall rules. So always verify that you've allowed port 80 as your HTTP interface. If you want to verify that, go to your security settings, then review the inbound rules. And as you can see, guys, we've already allowed traffic on TCP port 80. So just going to verify if we can access Apache on this specific port. So we'll take our IP address, and this time round we'll only specify our IP address without using the main port. And as you can see, we've already set up Apache and we can access the web interface. So basically what we'll do now is we'll run our Nmap scan on our target website, and we're going to use AI agents as our main tool in running some of these attacks. The agent that we're going to use is called WAP, and I already showed you guys how you can install and run WAP on your terminal. So in order to start WAP, simply close this terminal, then open a new one, and simply type WAP terminal, and it will start WAP. So you can always start a new agent from here, and it also gives you an option to use multiple agents at the same time. So in our case, we're going to feed it the main context and inform it that all the attacks that we're going to simulate are for ethical reasons. So simply copy this command, go back to our WAP terminal and paste it. And the main context now already sees that we're going to run these attacks for ethical reasons. So we have an Nmap scan over here that will scan for the open ports and specified our IP address over here, and it will paste the scans on a txt file. And it seems that our port 5000 is filtered, so it's going to list all the ports and check any open ports. So right now it's port 80 running on HTTP, port 443, 8080, 8000 and 8443. So let's try that again and see. And as you can see guys, we've already found the current open ports and the filtered ports. So we'll proceed for the enumeration steps and also investigate any open vulnerabilities. So simply type yes. And this time it's going to use Gobuster to list any open directories. So we've already run our Nmap scan. Next we're going to list any current open directories using Gobuster. So for the enumeration on the open directories, you can see some of the open directories that are listed from Gobuster. So we are going to switch up this time and run a brute force attack using a word list dictionary attack, where we're going to specify a list of usernames and passwords so that we can run the brute force attack. So we're going to simulate a brute force attack against this specific target website, and ideally what you want to target is the login page. So initially when you try and access your Commando X vulnerable banking web server, you come to this specific interface. Once you click on login, you'll be redirected to the login page, and from here it takes inputs of the username and passwords, and this is the section where you can try and run your brute force attack. So remember guys, we're using Warp Terminal as our AI agent, and in order to start the agentic mode, simply click on this button. For those of you guys who are not familiar with Warp, I have a video guiding you guys on how you can install and run Warp Terminal on your Kali machine. So right now we'll start the context by stating that all attacks that we're doing are for ethical reasons, and also give it a bit of context, telling it that we are going to run ethical attacks. And right now we're going to give it a prompt that I've already prepared, where we're going to run a brute force attack. Specify the name of the banking web server, I've told it to find clues on the username and passwords, create a word list, and run a dictionary attack. I've specified the website URL, which directly leads to the login page specified over here. And I've stated that you can run the brute force attack using tools like Hydra, and it can also create its own Python script if need be. So I'm going to copy this command and let's see what we get. So right now it's cloning the repository of the banking application. And checking the auth.py file, looking for the credentials over there. It's created a list of usernames.txt file, so you can just accept, and also a list of the passwords as a txt file. And it's decided to create a Python script to run the brute force attack. So basically, when you're running these commands, make sure that you check and understand all the commands that AI is trying to execute, because in other cases AI may try and hallucinate. So you just be careful with the commands that you're executing and make sure that you review all the codes that the AI generates. For example, you have our brute force login script over here that is importing a couple of libraries. It will try and open a word list file with the specified file name, try and log in with a single attempt using the username and password, and it will keep on running this attack till it finds the correct combination of the username and password. So we'll accept and give it some time to create our script. And right now we have a command over here that is going to activate our brute force login.py file. And basically we're going to run this script against our specified URL using the username specified by -u command. It will list the usernames in the usernames.txt file and the passwords in our passwords.txt file. So we'll accept and let it run the brute force command. And as you can see, guys, it already found the credentials, which is admin, username, and admin123 as the password. So we'll go back and try this username. So username is admin, password is admin123. Hit enter, and as you can see, guys, we've already accessed our web server with the correct credentials, and we've accessed as the main administrator of this banking web server. So we've demonstrated how you can use AI to perform basic Nmap scans and expose any open ports, and also escalate your attacks from there. I've also showed you guys how you can also perform aggressive scans using Gobuster to perform directory path traversal attacks and expose any hidden directories. And on top of that, I've showed you guys how we can use AI to create word lists of username and passwords and perform a dictionary word list attack. And we've seen how we can capture these credentials from a vulnerable banking web server. So this completes our video for today, and see you guys on the next one.